Hope you're doing good. This is Mani and I'm back with another video. In this video, we will discuss about what are the topics we need to know in SQL as data engineers. In data engineering, we know that we deal with a lot of data and different types of data as well. To put it simply, the data in data engineering processes can be categorized into three different buckets. First one being the structured data, where we will receive the data in terms of columns and rows. Basically, it will resemble a table-like structure like you see in an Excel sheet. And this type of data we will get from a database or a CSV file or some text file, right? And the next type of the data is semi-structured data. When we have API output, we will most likely get in two formats, that is XML and JSON. These two are loosely structured data. They have some structure to it, but they will not follow like a strict guideline on how the data is structured within those objects. So this is second type of data that we receive. The third type of data is unstructured data, right? The unstructured data is nothing but your photos, videos, PDFs, log files, so on and so forth. These doesn't have any structure at all, nor they follow any data model. So we will end up getting lots of data, but in a very unstructured format. So when it comes to like analyzing the data as data engineers and outputting our data to different stakeholders, we do it in structured data or in tabular format the most, right? So this is one of the very preferred type of data when it comes to analysis, right? And we use SQL to dive deep into the data, perform many tasks like cleaning, analysis, transformations, and creating views or tables out of it. So SQL is very helpful in this regard. Now we will discuss about what all the like different categories of operations or queries that we use in SQL. The above slide contains all the important topics that we as data engineers should know in SQL. These are divided into different sections. First one is uh, table or view operations. Second one is data retrieval. Third one is data manipulation, aggregations, joins, Windows functions, set operations, and other important topics. Right. Let's go through the first section. Table creation or view creation operations or view operation. If you want to create a table and like store the data, to store the can use create statement. If you want to make any alterations after the fact that the table is created, we can use alter statement, truncate to delete all the data that is present in the table, but retrieve the table structure as is. And if you want to drop the table, we can like entirely drop the table without having a trace of it using the drop statement. So these are all the different operations that we normally perform on a day-to-day basis as data engineers. The next one is data retrieval, and select statement is like a print statement in our programming language, where if we want to retrieve the data and display it on the screen, we can use select statement. We have where clause with the select statement where we can filter out the data and display only the particular set of data that we want. And we have aggregation statements like count, min, minimum, maximum, or min max, sum and average to provide a certain metrics of a particular column within the select statement itself. The next step is data manipulation. Once the data is present in a table, and if you want to like made modifications or add some data to that particular table, maybe add a row or update a row or even delete a particular row, we can use insert, delete, insert, update and delete operations respectively, right? The last one is merge in data manipulation. Suppose if you have an orders table in a database and it is continuously receiving updates based on what is the status of the order, whether it is order is placed, next one is shipped, next one is order delivered. So if you we will like receive all of these updates to a database. In data warehouse though, we need all of these different stages of the order to be present in our data warehouse, and That will help us to calculate metrics based on how faster we could deliver the order, and what is the like average amount of time that is taken to like process certain type of orders. So the to achieve this, to achieve the history of the particular order, uh, um, history details of the particular order, we need to use merge operation. Merge is nothing but insert and update. Once if you have already a record present already in the particular warehouse table, if you if you want to update that particular table with the latest status of that particular order, then we can use merge statement. If there is no record present for that particular order, if this is a new order that is placed, then we will just simply insert that. So this is how merge statement works basically. The next one is aggregations. If you want to aggregate the data and only show it with the relevant details, then we can use aggregations using group by. So suppose if you want to check all the orders placed by region, okay, for every different city that we are operating in, if you want to check what is the count of like orders placed in different regions. So if you want to do that, then we can use group by statement. So suppose if we get like zero orders from particular city, and if you don't want to include them, in fact, when we apply the aggregation, we will get which have or cities which have zero counts, right? If you want to not include those, then we can use having operations. If you want to order again based on the number of orders in the descending order, then we can use order by statement. This is how aggregations work in SQL. Next one is joins. If you for any department, the data relevant data for a particular operation, business operation, right, that will span across multiple tables. If you want to retrieve all of the data into one single place, then we will use joins. Different types of joins are present, like in your inner joins, left join, right join, full outer join. Based on our use case, we will use these joins. Suppose if we want to retrieve only the data that is present in both the tables, uh, then we can use inner join. For a join to happen, though, we need a common element between these two tables. For example, customer the information is present in one table, and the second table is order table where we have only the customer ID and rest of the order information, right? If you want to retrieve the phone number, we need to make a join between the orders table and the customer table to retrieve the phone number or email address for that particular customer. So this is how joins work. And for left join though, between these two tables, one will be tagged as left and the other one will be tagged as right. If we use a left join, all the records from the left table will be retrieved, and only the common elements that are present between these two tables from the right table will be displayed in the left join. Vice versa is true for right join, where the right table, all the rows from the right table will be displayed, and the all the relevant uh, rows from the left table will be displayed. Only the matching records here, right? If there is no match for, for the right table in the right join, the left table columns will be left as blank, and when there is a match, the data will be populated. This is how joins work basically. Next up is Windows functions. Windows function is nothing but if you want to retrieve a data or calculate a metric based on a window of time or window of values, then we can use Windows function. Suppose now, for example, if we have orders table and we need to calculate the running total of the orders for every week starting from 2021 to current date. So what we will do is we will use a Windows function where we will order the data based on every week starting from 2021, and we will calculate we will aggregate the data based on each week. So this is how Windows functions are used. And if you want to order the data based on a particular window, like a month or a particular set of values, like based on the department or based on unique values found in a particular column, we can use the Windows function and we can calculate the like we can order them using rank, we can order them using row number, we can order them using dense rank. So these are like very helpful functions in our data engineering workloads as well. Suppose if you want to retrieve only the latest records for all the order IDs from the orders table where we have multiple updates for each order, right? We can use the row number function within the Windows functions, or analytical functions is another name for Windows function. We can use the row number to retrieve the uh, latest records for each order ID. So this is how Windows functions are used. It is very helpful to know Windows functions. There are important, interview questions like how to calculate the nth highest salary of an employee. So we can use Windows functions for that as well. Next one is union table. Suppose we have identical tables, two tables with identical data and identical column arrangement as well. We can, if you want to combine the data from these two tables, from table A and table B, then we can have the union operation done. For joins, the number of columns increase. For union, the number of rows will increase. So this is the difference between the two. The next step is the cities and UTF and stored procedures. Cities are nothing but common table expressions. Suppose you have a very lengthy SQL query that has multiple inner queries, and each inner query will deal with separate set of business logic. If we have like that query written as is without any formatting, then it will be very hard for any person to comprehend that query quickly or easily. So cities are where the code can be arranged in different blocks, and the we can use the output from the above block in the below block right next to it, or anywhere within the city going further, or we can have a different functionality within each block, and you can use the data in the final block city to retrieve the data. So this is how cities work. And we have UDFs as well. UDFs are nothing but user defined functions. User defined functions are nothing but, suppose you have a custom business logic. If you want to apply on multiple columns to uh, like calculate a metric, or to like have a status or new metric derived out of it, we can use UDFs or user defined functions. The last one is stored procedure. Suppose if you want to retrieve a data and provide it to a stakeholder every day. So in database world, we can use stored procedures. Stored procedures, execute a piece of SQL code every day based on a schedule, and dump the data into a table, a database table, or even export that as a CSV file or an Excel file. These are all the important functions used in SQL for a data engineer. There are of course many others as well, but these are very necessary concepts or topics that we need to cover as data engineers in SQL. Last but not least, I'll also include all the necessary resources to for you to prepare on SQL and practice your skills on SQL, because SQL is one skill that requires a good amount of practice to understand what we are doing with the data. So if you want to like follow a path in becoming a data engineer, or craft your skills in data engineering space, I'm preparing a guide that is present at learndataengineering.guide. So this is a very simple guide that focuses on core skills for a data engineer, like data skills, software engineering skills, and some data orchestration tools, and other important skills as data engineers. So in a modern data engineering world, we need several skills. So all of these steps, different stages of a data engineer is explained in this particular guide, and what all the skills that you need to prepare for each different phase, or each different section. So I have ordered these skills in different phases. So the first one is of course the data skills. For a data engineer, it is very important, and uh, one of the prominent data skill is SQL. So each section again will be as a different page where you will find like what are the different important topics for that particular skill that needs to be understood, and what are the skills, what are the different sections that we need to learn with them. I'll also include the resources in the coming days, and you can like follow this guide to get a good grip on your core skills. So the topic that the slide that we have discussed is also included here for your reference. Please let me know how you like this particular guide, and I'll be looking forward for your feedback. If you have any comments on this video, please link in the description below.